So calculating scale factor. So yesterday we looked at scale factors or scales. It's your diagram number on top and your actual number on the bottom. And so it could be a fraction. Okay, so sometimes when I'm doing this with proportions, I always work with the fraction. And I really like the fraction. I find it's the easiest, especially keep in mind the units. Okay. When we're not doing a fraction, you can turn it from a fraction to a decimal. But the problem with working with a decimal is you don't know, should I multiply or should I divide? Okay, so that's a bit of the problem. The bit of the problem with the decimal is you don't know if you should multiply or divide. Okay, and that's why I like working with the decimal and only the decimal. So I like working with the fraction and only the fraction. Okay? So you don't know if you're going to multiply or divide. Now, today, they're going to use some new terminology. So for your scale factor, which is kind of your scale, you can talk about a new over an original. And that's because they talk about making diagrams. So when they're saying new and original, they're kind of talking about the new image versus the original image. Okay, so some of the language in the homework questions are going to be slightly different. And that's okay, though. We're still doing exactly what we looked at yesterday. Okay, diagram over actual. All right. Any questions about that? Okay, so going forward then, okay, we want to use a proportion to determine the scale factor, and we want to work with that proportion. So again, we will know the scale factor, and we set it equal to another ratio. So let's look at this example number 1. Okay, the words matter. So on the drawing, so the drawing in yellow is 0.5 centimeters, but the actual height in blue is 20 centimeters. So what can we do with our fraction? Well, the scale factor equals the diagram, okay, diagram over the actual, D over A. So our diagram number is 0.5 centimeters, and our actual number is 20 centimeters. The units, because they're the same, they cancel out, and we can turn the 0.5 over 20, we can use that in our proportion. Or we can turn it into a decimal, and we can go 0.5 divided by 20, 0.5 divided by 20 equals 0.025. And we can work with that. Now down below, they also turn this into a fraction, so the smallest number is a 1. Okay, and that gets a little weird for this question. For this question, that would turn into 1 over 40. Okay. So I don't really like this question that much. We're probably not going to do something like that. Now, remember, I'm going to change this here. I don't like the way this is organized. You have enlargements and reductions. So for your scale factor, if your scale factor is larger than 1, that means you have an enlargement. Because when you multiply it, all your numbers would get bigger, going from your diagram to your actual. Okay? So it'll be like timesing by 2, timesing by 3, whatever that is. All right? If it is smaller than 1, then it is a reduction. Now, smaller than 1 can be things like 3/4. It can be things like 75 over 100. It can also be in decimal format, 0.75. All those are less than 1. Any proper fraction is less than 1, and decimals that do not have a 1 in front will be less than 1. Okay? Like even 0.2, 0.2, that is less than 1. So those scale factors would be a reduction. All right. So most of the time what we're going to do is find your scale factor and make your proportion and solve. Okay. You got to make sure, though, that you have the exact same units. Yeah. What, we just need to school now? No. Oh, okay. Anyway, so they asked them. Okay, so make sure that you have the same dimensions for a scale factor. So for example, in this question right here, we have inches and feet. So in blue, the diagram is 8.5 inches. It actually measures 12.75 feet. You can't have inches and feet for a scale factor. Okay? If you're looking at the scale, you could use 8.5 inches over 12.75 feet. Okay? You can work with that. However, if you're doing a scale factor, you have to turn this into inches. So if you turn that into inches, you'll get 12.75 times 12. Okay. So I'm converting my feet into inches. I can get 153 inches. So then I can come up with my scale factor, which is 8.5 inches over 153 inches. My inches cancel, and then I can divide to get the scale factor. 8.5 divided by 153. And you get 0.5 repeating, 0.05 rather, I believe. Yeah. Okay. And you can work with that. Mr. Barker really likes working with the proportion. So when you're actually doing real work, use 8.5 inches over 12.75 feet. However, on your other fraction, what units must be on top? Inches. And what units would you be finding then on the bottom? Feet. Okay? That's the trick, is you got to remember what units are on top and what units are on the bottom, and it has to stay that way. Any questions? Okay. So let's go down and do the next notes. Oh, we did a little example here. Let's do one more example. Okay. So one more example, we have 50 centimeters and 3 meters. Find your scale. Your scale, okay, as a fraction. The difference with a scale is the units can be different. Okay, go for it. The diagram of the car is 50 centimeters. The actual measurement is 3 meters. What would be your scale? What's the fraction? Well, it would be 50 centimeters over 3 meters. And you could do all your work with that. Okay? But the question is asking for your scale factor. Then your units have to be the same. So you'd have 50 centimeters over how many centimeters? What would you do to convert the 3 meters into centimeters? Well, where's my meter stick? Here we have 1 meter. How many centimeters do you think are in here? I'll give you a hint. The width of my hand is 10. Does it look like there's 10 centimeters in here? Kind of looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups of 10. How many centimeters do you think there are in a meter? 100. There's 100. This would be 100. 10 centimeters is about the width of your hand. So you multiply by 100, and you get 300 centimeters. Okay. So my scale factor would be 50 over 300. And that would be fine, but you'd probably want to put it in lowest terms. Okay. So we go from 50 centimeters to 1 centimeter by dividing by 50. And if we divide the top by 50, what would we have to do to the bottom? Divide by 50 as well. Okay. And you get 6. How come I don't have centimeters? Because they cancel out. Okay. So you get 1 over 6. Personally, again, Mr. Barker likes working with the scale when I do my work because I don't have to worry about changing units. But if the question is specifically asking for the scale factor, well, then you have to work with the scale factor. Okay? Questions, comments, or concerns? So you're doing these homeworks. Here, right, when you're finding a scale factor, you want to match up, okay? You want to match up like measurements. So I would compare the leg measurements. I wouldn't compare the leg to the length. No. I'd compare leg measurements. I'd compare width measurements. Oopsies, that's supposed to be blue. I'd compare width measurements. And then I'd compare length to length. So compare leg to leg, width to width, height to height. You can't compare different measurements from different parts of the objects. It doesn't make sense. Okay? Good. Let's write down these words. Sometimes, right, the scale factor, they use the words new and original. Sometimes they use the words drawing, model, or diagram. And on the bottom, sometimes they use actual and real. Actual and real. Okay, so you got to make sure that you understand these different vocab words, what they're referring to, the top of the fraction or the bottom of the fraction. Okay, so make sure you got those written down. Any questions? Got these written down? Got these written down? Write these down. Write these down. Okay. Where are we here? So this is just more of the same, exact same thing. Okay. So let's not even go there. Okay. Once you got these written down, then you can get started. So today we're doing 5 and 6. No. Sorry. We're doing 6 and 7. Okay. So your work today is, let me write it down here, assignment number 6, 7, and then you're doing quiz 2. Most of the other class got this done with 20 minutes left. Okay, 6, 7, quiz 2. Questions?